Okay, so welcome to chapter 6. Chapter 6 is all about what are just some different applications that we can do with integration, similar to how chapter 4 was let's take derivatives and apply it elsewhere with the whole curve sketching and optimization. So today, and for the next video too, we're going to be talking about area between curves. So there's a worksheet that I would like you to do. It's in Canvas before we continue. So why don't you just take some time and do that now? Okay, so I hope you did the worksheet. So the idea was, our question is, what is the area bounded by, if I just have two functions, and the lines x equals a and x equals b. So to draw an example, let's say I have these two graphs. I want to say, well, what is this area? Okay, so that's not quite the area under the curve, right? But maybe we should approach it as area under the curve just to see if we can somehow use integrals to find out what that area is. So I'll call the top one f and the bottom one g. If I look at them separately, so I have f, the area under the curve for f between a and b, it's going to look something like, I'll draw with horizontal lines, something like this, right? That's the area underneath f. What about the area underneath G? It's not quite underneath because remember, the area underneath the curve goes from wherever the function is to the x-axis. The area we want, I'll draw vertical lines for, is this little bit. And so, our total area is a lot similar to what we have there. The only difference really is we want to take out these overlapping parts. But when g is a positive function, and this is just a little bit, if you didn't see it, it's fine, but if g is a positive function, it's really, let's take out that little bit. If g is negative, though, we need to add it to get our extra area. So really, what this turns into is we can actually use an integral where we subtract, we take the top minus the bottom, take the integral dx. And that's the entire idea behind finding area between curves. So for the rest of the time, we're just going to look at some examples. Okay. So just to see it in practice what that idea is like, let's try to find the area bounded between x minus 2 quantity squared, y equals x equals 1, and x equals 4. What does this look like? Well, you have the line x equals 1. Looks something like this. X equals 4 is over here. And then we could plot points with this parabola, and what you'll get is a parabola that looks something like this. I'm not making it U-shaped enough, but apologize for my... Oh, that's why. Sorry, those points need to be down here. Okay. And just to distinguish it, let's put it in a different color. Okay, so that's our function y equals quantity x minus 2 squared. What about the other function, y equals x? That's all we have left. Well, it's this line. So if you want to look at the area in between all these, that's going to be this area. So to use the idea that I just talked about, we have to say, okay, first of all, what's my function on the top? Well, that's y equals x. What's my function on the bottom? It's y equals x minus 2 quantity squared. And then what's my bounds of integration? So to find the area, it's going to be 1 to the 4 of x dx minus 1 to 4 of x minus 2 quantity squared dx. And this is all coming from that x is my top function subtracting bottom function. Okay, the first one, we can do that integral pretty easily. But then for the second one, this is a something quantity squared. I can expand this, or what I'm going to do is you could do u sub. You could do substitution rule. Take your u to be x minus 2. So du over dx is 1. That is du equals dx. So this is the integral of u squared du. And to find the limits of integration, the little numbers, you just plug them into u. What do you get? 1 minus 2 is negative 1. And then 4 minus 2 is 2. Okay. So then this first one will be 16 over 2 minus 1 over 2. And then minus, what is the integral of u squared? Well, it's u cubed over 3. Evaluated from negative 1 to 2. So this is 8 minus 1/2 minus 2 cubed is going to be 8 over 3. And then minus negative 1 over 3. And this is when you go and plug this into your calculator. So it's 8 minus 1/2 or 0.5 minus 8/3 plus 1/3. And you'll get 9/2. So that's the area bounded between these two curves, is 9/2 or 4.5. Okay, so Let's do more examples. I'm going to want to look at the area bounded between y equals 1 over x, y equals 1 over x squared, and x equals 2. But this is looking a little bit different. I'm only given one of the bounds of integration. So let's graph this and see what happens. Well, if you graph 1 over x, and we're only going to stick at the positive right now, what do you get? Well, you'll get something that looks like this is 1 over x, and then you'll get something that's coming down a little steeper for 1 over x squared. And it gets down close to the 0 faster. Now where is x equals 2? Well, that's somewhere over here, actually. So let's draw in a different color. What we're looking for is this area. Notice that we can talk about the area bounded between curves because they intersect. Now, where do they intersect? Now, because of the particular functions we have, you might be able to just say where they intersect just by looking at them. But if we don't know, we have to solve these equations. Where are they equal to each other? Okay, so multiply both sides by x squared, and what do you get? You'll get x equals 1. Right, because x squareds will cancel on the right, and then on the left you get x squared over x, or 1. Okay, so at this point the x value is 1, which means now that we're going to want to integrate, we're going to do the integral from the left, 1, to the right, 2, of the top function minus the bottom function. Top function here is 1 over x. You can verify that in calculator. So 1 over x is on the bottom whenever you have an x less than 1, but for x greater than 1, it's on the top. And this is going to be our area. So that means 1 over x squared is on the bottom, so you subtract it. And I'm going to write this as x to the negative 1 minus x to the negative 2 dx. And we can find the antiderivative. Remember, the antiderivative of x to the negative 1 is natural log of the absolute value of x. And then it's going to be minus x to the negative 1 over negative 1, evaluated from 1 to 2, or natural log of the absolute value of x plus 1 over x, evaluated from 1 to 2. What does that give us? Natural log of 2 plus 1/2 minus natural log of 1 is 0 plus 1. Or, as a final answer, the area is going to be the natural log of 2 minus 1/2. You have to distribute that negative. And that's just some number. It's not a pretty number, but it is a number. So I have some other additional videos posted today I would recommend looking at, getting more examples and more practice with this idea of the area between curves. And we'll continue this tomorrow, talking more about this idea.